Andrea Suasi F. Ibay.
And I am Diana K. Iliano, and we are the leaders of this group. Before we begin our presentation, allow us to introduce our members.
Hi, I'm Arch Andre F. Ibay.
Hello, my name is Alden Olustina.
Hi, my name is Juliana K. Tilusas.
Hi, I'm Jeremy Marcaida.
Hi, I'm Joshua Sandrina F. Manzano.
I'm Dylan K. Cosan.
Hi, my name is Mark Franklin Laguna.
So, hi, I'm Jerica Tadeus Agustin Hamanje.
Today, we are going to present to you the CV1 of the month of October, which is about sequence.
A mathematical definition, a sequence is a succession of numbers in a specific order. Each number in the sequence is called a term.
These are the examples of sequence. The two types of sequence are the arithmetic sequence and geometric sequence.
Hello, I am Andrea Suasi F. Ibay, and today we are going to talk about arithmetic sequence. An arithmetic sequence is a list of numbers with a definite pattern. If you take any number in the sequence, then subtract it by the previous one, and the result is always the same or constant, then it is an arithmetic sequence.
This is how to solve an arithmetic sequence.
Calculate the 13th term in sequence 1, 4, 7, 10, 13, 16, 19, and 22. So the first step is find the first term, which is 1, the common difference, 3, and the end term, 13. The second step is to write the formula. An equals A plus n minus 1 times D. The third step is substitution. After you substitute, your equation should look like this. The first thing that you're going to do is subtract 13 minus 1. The second is multiply 12 by 3. And then add 36 plus 1. And the answer is A13 equals 37.
Hi, so now we are going to find the 125th term of 4, negative 1, negative 6, negative 11, negative 16, negative 21, negative 26, and so on. So the first term is 4. The common difference is negative 5. Now, we have the equation an equals a1 plus, open parenthesis, n minus 1, close parenthesis, d. So we are going to find the 125th term, so you are going to write it down here and here. So a125 equals 4 plus 125 minus 1 multiplied to negative 5 equals 4 plus 124 multiplied to negative 5 equals 4 plus negative 620, and the answer is negative 616. Now, the 125th term is negative 616.
So, hi, I'm Jerica Tadeus Agustin Hamanje, and I'm here to explain the example that I made in arithmetic sequence. So, first, the formula of arithmetic sequence, and the formula of arithmetic sequence is a1 plus n minus 1 and d. So the example that I made is find the 35th term in the arithmetic sequence 3, 9, 15, and 21. So our first term is 3, and our difference is 6. And lastly is the n, and it represents as the 35th term. So let's move on our solution. So the solution is an equals a1 plus n minus 1 d. Next is a35 equals 3 plus 35 minus 1 and 6. So we can see here that the n became 35 because we can see that the n, it represents as the 35th term. And we can see that a1 became 3 because our first term is 3. And the d became 6 because our difference is 6. So next is a35 equals 3 parenthesis 34 parenthesis 6. So So it became 34 because we subtract 35 minus 1. And next is A35 equals 3 plus 204. So, and next is and it became 204 because we multiplied 34 to 6. And next is A35 equals 207, and it became 207 because we add 3 and 204. So the final answer is 207.
Hi, my name is Mark Franklin Laguna, and now I will give an example of arithmetic sequence. This is my example of arithmetic sequence. Find the 50th term of arithmetic sequence 2, 7, 12, 17, 22, 27. A is equals to 2, which is the first term, and D is equals to 5, which is the common difference of 2 and 7. N is equals to 50, which is the number of terms that we will count. So this is the formula of arithmetic sequence. An is equals to A plus close and open parenthesis N minus 1 close and open parenthesis D. A50 is equals to 2 plus 50 minus 1 close and open parenthesis 5. And we will get 2 plus close and open parenthesis 49 close and open parenthesis 5. And we will get 2 plus 245, and we will just add it, and we will get 247. And that is the arithmetic sequence.
Geometric sequence is a sequence of numbers in which the ratio between consecutive terms is constant.
Hi, I'm Jeremy Marcaida. This is one of the examples of geometric sequence. As we can see here, we have the sequence 400, 200, 300, and so on. In this sequence, we should find the next three terms of the following geometric sequence. The first thing we will do is to find the common ratio. For us to do that, let's divide the 100 to 200, and it will become 100 over 200. And if we lowest term it, it will become 1/2. Then 200 over 400 will become 1/2. It probably means 1/2 is the common ratio. The next thing we will do is to find the next three terms. Let's start with 100. 100 times 1/2, or should I say 100 times 1 divided by 2 is 50. Then 50 times 1 divided by 2 is 200. And the last, 25 times 1 divided by 2 is 12.5. The final sequence is 400, 200, 100, 50, 25, 12.5. And that's the first example of geometric sequence.
Hello guys, my name is Algin Lustina. So this is an example of a geometric sequence. In this sequence, we will calculate the 10th term in the sequence 5, 30, 180, 1080, 6480, and so on. But first, we will find the values of A and R. So in the sequence, our first term is 5, so A is equals to 5. Then to find the R, or common ratio, we will divide the second term to first term. So 30 divided by 5 is equal to 6. So the next one is to write down the formula of a geometric sequence, which is A sub n is equals to A multiplied to R raised to the power of n minus 1. Then we will utilize the law of substitution to replace the variables to the given values. So n into 10, A into 5, and R into 6. Then we will simplify 10 minus 1, which is 9. Then 6 raised to the power of 9 is equals to 10,077,696. And lastly is to multiply 10,077,696 to 5, which is 50,388,480. So that is the 10th term of the geometric sequence.
Namamas ko po! Namamas ko po!
Mamas ko po!
Namamas ko po!
Namamas ko po.
Happy New Year!
Namamas ko po.
Namamas ko po.
Happy New Year!
Mamas ko po.
Namamas ko po!
Namamas ko po!
Happy New Year!
Happy New Year!
Happy New Year, everyone!